Hello everyone. In today's video, we are going to explore a fascinating function that combines an intelligent recursion with the sharpness of absolute value. We are given a piecewise defined function as you can see on your screen. The function defines as follows: the fx is equal to 1 minus the modulus of x minus 2. And this definition is only for x lies between 1 and 3 inclusive, and beyond this interval it follows the rule f of 3x is equal to thrice of fx. The question is, how many points in this open interval 1 to 100 make this function non-differentiable? So here is our plan. First, we will understand how the recursive definition works and how to build the function by explicitly defining it across different intervals. Then in the second part, we will see how we don't need to define the function step by step at all. We can visualize the recursion and let the pattern reveal itself. For this, we will start by plotting the base function, and from there we will watch how the shape transforms as the recursion unfolds, and at the end the graph itself will lead us to the answer. Let's dive in. So what we can think as a beginner, we can see that the function fx is defined in the piecewise form in this way. When x is lying between 1 and 2, I can write this x minus 1 as this will open with a negative sign, so it will be simplified to this x minus 1. And this function will be 3 minus x when x lies between 2 and 3. So this is the base function we have, and we have to define the recursion first. So I have already given f of 3x is equal to 3 times fx, and we have to find the recursion relation. And for that, we can see what is that. I have the value 3x is thrice of x. You can see that. It means, suppose I'm substituting x equals to 9, the f9 should be the thrice of f3. And in this way we have to build up. So how we can build? Suppose I'm substituting there x. It means on the right hand side, at the place of x, it should be x by 3. It means again this f of x by 3, I can use it like this. What I'm saying that I can use this f of x by 3 as f of 3x. So I can again make this iteration, and we can write this as 3 times f of, and the input is now 1/3 of the previous input, so that will become x by 3 squared. As you can follow, you can see that this will give you 3 square f of x over 3 square. Similarly, we can see that again this part can be treated as the original fx, and the iteration will lead us to write one more time, this is 3 times and f of the 1/3 of the previous input, so it will become 3 to the power 3, and so we are getting that 3 to the power 3 f of x divided by 3 to the power 3. You can see what is happening here. I can say that this was the first iteration, this was the second iteration, and this was the third iteration. So basically I want to find what is the nth iteration. It means the function itself, if you want to write the fn x, or maybe the fx also you can write, is 3 to the power n f of x by 3 to the power n. Means in each iteration I have different definition of the function. We combine them all to write this fx, and n starts from 1 and it goes up to n or whatever you want. So the thing is, what is the first definition you can say? So f1x, if I write for n is equal to 1, that must give you 3 of f of x by 3, as we have already found. It means that I have to substitute this x by 3 in our original function here. And what is this original function? Let me write it here somewhere. So I have the f of x, it was 1 minus modulus of x minus 2. And this thing I have to use again and again, but with some caution actually. So what we can do it, I have to substitute x by 3 there, but you see that this definition is only meant for whatever I am substituting here, that must lie between 1 and 3. So I will define here this thing as x by 3 lies from 1 and 3, and so x goes from 3 to 9. It means in the next iteration, that is f1, I will have thrice of f of x by 3, that means thrice of 1 minus, and at the place of x I am able to substitute now x by 3, but the condition I have to follow this thing. With this condition, 3 to 9 I have to define this function. In the same way, let's define n is equal to 2, and you can understand what I want to say. It will become now 3 times, not 3 times, so 3 square times f of x by 3 square. So 9 times f of x by 9. But now the problem is, again, x by 9 we have to use by the definition from 1 to 3. So I can write that x by 9 should lie between 1 to 3. It means x should lie between 9 to 27. It means you are using the same very definition, this definition, but for 9 to 27. So this will give you 9 times 1 minus, and the place of x now I am able to substitute x by 9 minus 2 and so on. You can also think in this way. This is 3 times f of 1 by 3 of x by 3. You can see what is happening, and also it's a actually thrice of this. Let me write it. So you can see what is happening. It's a 3 times, and this is nothing but in the previous function, this 3 times x by 3 times of f of x by 3, we are substituting x by 3. It means that to find f2, you are writing 3 times of f1 x by 3. So every next function you are building is a thrice of the previous function at x by 3. It means 1/3 of the previous value. So in this way, if you want to build up the next function, that is next part of this function, n is equal to 3, so f3, that's third definition, it will give you directly, we can write as a 27 and 1 minus and x by 27, as you can follow this thing, mod, and the x should lie from now 27 to 81. You can see that every interval is like this, 9 3 are 27, so 27 3 are 81. And so you can see that we have to stop at 100. So from 81, if you start the next function, it will goes up to 243. So if you stop at 100, so still there is some part we can write here. So we can write n is equal to 4. f4x is nothing but 81 and 1 minus x by 27 times 3 is 81 minus 2 mod, and this is going from 81 to, and I stop at 100, but still there is a definition. Now the problem of this approach is we have to again redefine each of this f1x, f2x, f3x and f4x in this way. That is a piecewise defined function, and we can see then in how many points this function is not differentiable. You can see clearly that this function is non-differentiable at only one point, at 2, because at 2 from the left hand side the derivative is 1, and at 2 from the right hand side the derivative is -1. In the same way, if you define the f1x by breaking it down into the pieces, you can realize that it is going from 3 to 9, so the break will happen at 6, because at 6 this is going to be 0. So from 3 to 6 and 6 to 9, so there's a modulus break. If you see that the corner point at 6, so this will give you the point of non-differentiability at 6. This will give you the point of non-differentiability at 18, and this will give you the point of non-differentiability at 54. So far we got 4 points of non-differentiability. Here is at 2. Let me write it somewhere. So far how many we got? That is the at x equals to 2, then we got 6, then 18, and then 54. But also you can see, because each next interval is starting from the end of the previous interval. It means the first interval was 1 to 3, the second was from 3 to 9, correct? Then second was from 3 to 9, so third is 9 to 27. So at each end where there's a connection is happening, there is also no differentiability can happen, and these are the points at which non-differentiability can happen. There is 3, then 9, then 27, and then 81 also, because after 81 till 100 we have to also give one line segment, and 81 will make a corner. So in that way we got 81, not 81, sorry, 8, yeah, 8 I have already written, so 8 points of non-differentiability. In this approach we have never visualized anything, and we have to redefine all these things, so it's a tedious work. Let's go for a second approach in which we will understand all the things graphically. So here is our graphical approach, the second approach. So as you can see that there is no such big deal in drawing a graph of this function. So already I have drawn it to make the life simpler. So I have 1 minus 2, not 2 actually, 1 minus modulus of x minus 2 from 1 to 3, from x 1 to 3. So you can see that anyone who is preparing for this JEE and all, this kind of graph you can easily draw it. So this is going to be mod of x minus 2 here, and since there's a minus sign in front, I have to invert it down and again shift it up. So from 1 to 3, this graph I have already plotted, and I'm not going to redefine any function at all, but using the recursion wisely. And how I'm saying wisely, let's see. I'm given that fx is 3 to the power n f of x by 3 to the power n. Let's now find out n is equal to 1. So n is equal to 1, you can notice that fx is 3 times f of x by 3. What is the meaning of this? It means that this is 2 I have written. Very sorry for that. This will be 3. So what is the meaning of this thing? That in the next interval for n is equal to 1, when you are iterating this thing, I have to follow this thing. And you know that very well. If you know this thing, that 3, this is the number we are multiplying to the function from outside. So it will give you the vertical stretch. Yes or no? Vertical stretch this will give you. It means it will be responsible to stretch the graph vertically. And this number, you can see that here 1 by 3 is multiplied. So 1 by 3 will be responsible for the horizontal stretch. When we multiply any number to the x and that number is more than 1, then it will be the value which will be responsible for horizontal compression. It means it will shrink the graph by that much unit. But here 1 by 3 is the number lesser than 1, so it will give you the stretch. How for? 3 folds. So this will give you a stretch, but the problem is this is the base function we are using again and again. So the next n is equal to 1. It means it starts from here only. And how do we know that it starts from here only? Because at 3, if you put the value 3, f of 3, it will give you thrice of f1, and f1 is already 0, so it should start from here. And I have to take the vertical stretch 3 units, and I have to take the horizontal stretch 3 units. So if you take the horizontal stretch 3 units, it will go up to 9, and the vertical stretch 3 unit means the same graph I have to draw, but you have to keep in mind the vertically it is going up to where? At 2 it was 1, so exactly in the middle of 2, 3 and 9, that is 6, it will go to 3. Yes or no? Because it was 1 there, so now it go to 3, so this will be 3 then, and I have to struggle with selecting the lines and all to draw the graph smoothly. So I have drawn successfully perhaps. So this is the graph we actually was intended to find in this interval. You can notice again what will happen for n is equal to 2. I have fx means the f2x, this was f1x, is going to be 9 times of f of x by 9, correct? It means this 1 by 9 is now responsible to give you the stretch horizontally of the base function, and this 9 is responsible to give you the stretch vertically of the base function. And where is the base function? This one. Or you can think in a different way also. This is 3 times f of 1 by 3 x by 3, as I also explained this thing in the previous part. So this is nothing but 3 times of f of 1 x by 3. It means now you can assume it as we are stretching the previous function f1x 3 times 3-fold on the horizontal axis and also 3-fold on the vertical axis. So now this 9, we are stretching this whole part, so this 3 shift to 9, of course you know that, and this will shift to 27. So I have to take up to here, and I have to draw a very, 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 very long line. If you substitute there x equals to 18, so don't you see that the f2 18 will become 9 times of f2? It means that the f of 2, whatever you found, so f of 2, what were the value? 1. And now I was saying that f2 18 is the 9 times of f2, means 9 times of 1. It means it will go to 9. So I have to draw the line which will ends at 9. So this will start from here. I have to start from here. Okay, so this is there and it will go till 9. So 9 is somewhere here at 18, and again it will come down. So how I show the come down, so that will go till 27 like this. And in the next part I don't have that space, but still I can say that now 27 to 81 will happen. It will shoot up very, very, very high, and it will be ended at 81. You can notice what is happening. It's 81. I think I overlapped this thing because my picture is somewhere here. I can make the size small and then we can show it perhaps, and then you can see. Yes. So this is now here, and after that what will happen? We can now substitute for the next part, and you can notice 81 to 243, and between 81 and 243 I have somewhere that thing. Can you notice our 100 will stop somewhere here, and till 100 I have to draw it. But in this whole pursuit, in this entire pursuit, you can think, oh, by the way, this is 54 here. You can see that I have to start from this one and to end it here, and you can notice the number of corner points easily, and then you can find out the total number of points where the functions are where the function is non-differentiable. So what is that? You can count. You don't have to count 1. So there's a 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 points of non-differentiability. You can again count. This is 1, 2, 3, 4, 5, 6, 7, and 8. You can also count like, because between two values, consecutive intervals, I have one local maximum point where the point of non-differentiability will exist. So already I have 1, 2, 3, and yeah, there's a 1, 2, 3, 4. Sorry, this I didn't count first. So 1, 2, 3, 4, and now these are the intervals ends. So there will be 3, 9, 28, and 81. So again 8 you can find like this. All right. Even if I increase this value up to 1000, you can simply find out the relation and get the idea how this is actually going to be. So this is the way we can think this recursion relation of a function graphically without turning everything into the piecewise function in different intervals. But as a good student, you should practice both of the methods. So let me give you some follow-up questions as your homework or whatever you can say. So that is the question. First question, a function f is defined such that fx is equal to 1 minus modulus of 1 minus x, 0 to 2, and fx is 2 times f of x by 2. Draw the graph of fx. Now there's a one catch. I can just give you the hint. The end point is 0 here, so the graph will never shift. So you have to draw it wisely by looking at the exact definition. The second question is a function f is defined such that fx is equal to 1 minus mod of 2 minus x, and x is again 1 to 3, but here I have changed something, the 2 times f of x by 2. And the question is, we have to find the area of the region under the curve f above the x-axis from 1 to 8. So I hope you will try these questions and enjoy the graph. See you in the next video. Stay math active.